So let's take a look at how we can ask SQL Server to return information about the partitions we created. In reality, most cases you don't care whether you're working with partitioned or non-partitioned tables. When you write queries against the database objects, the way that you do that is identical. SQL Server's query processor handles all those underlying details. You just want the results. As we know, implementing partition tables makes managing large amounts of data easier. But is there a way that we can write queries to work with those partitions directly? The answer is yes. SQL Server 2012 provides two mechanisms for working with those partitions. One is the partition functions, the other catalog views. Here we're going to discuss using the function and catalog views to retrieve information about partitions and the data they contain. The partition function returns an integer value between 1 and the number of defined partitions in that particular partition function. We'll use the partition function to determine how many rows exist in each partition. We can use that function to discover which partition a row with a given partition key value either exists or will exist if it's inserted into the table. We can actually use the function to retrieve all rows on a particular partition. And the key thing to remember is that the partition function will return the partition number of any valid partition key, whether or not the value actually exists in the partition table. So just because you get an answer from the partition function doesn't mean the row necessarily exists. The partition function has the following syntax, where optionally you can include your database name, and if it's omitted, it executes in the current context. The partition function name is the name of a defined partition function within the database you're working in, within the specified database. And the expression, that's either the partition key or an expression that matches the data type, or when it's converted, matches the data type of the partition key. So with this information at hand, let's go over to SQL Server Management Studio and take a look at some ways that we could use the partition function. In this example, we're going to use the partition function to retrieve the counts of each partition defined by our partitioning function and compare those counts to the original sales order header table that we used to import the data into our partition table. And here you can see that we are indicating here that we are going to use the partition function. There's our partitioning function that we defined a little bit earlier, that sales by quarter. Our order date is indeed our partitioning key, and we're just going to count the number of rows that fall into those particular partitions. Then we're going to take a look at the original table. We're taking a look at the sales order header table, and what we're doing here is we're simply going to use a case statement to count to really categorize or determine what bucket each one of the rows in that sales order header table would fall into. And those buckets align with our partitions. So of course we've done this by order date. So we're indicating here if the order date in the original table is less than January 1st, 2007, then that falls into bucket 1. And then we continue on for each of the 4 quarters in 2007, and then finally 1 for anything beyond 2007. And what we'll do is we will count those as well. And what we'll do is when we go ahead and execute this query, we'll get results returned from the partition function and say, hey, here's how many rows I have in each partition. We'll compare that to the count in the original table based on those date values, which really represent the boundary values of our partitions. And if all goes well, we should see them coming back equaling each other. So let's take a look at this. We'll go ahead and execute it. And sure enough, here we have alignment on partition 2, 3, 4, and 5. And we can see that this is the bucket, so to speak, that we created based on our case statement, looking at the range of dates in the original table, and we can see that not only do the buckets/partitions align, but so do the row counts. So just a way of kind of proving to ourselves that the partitioning function is working as we expected. We'll close this example and take a look at our final one here. In this example, we're going to use the partition function to indicate the partition number rows with a given order date appear or live in. So what we're doing here is simply saying, hey, give me back the partition. Remember, it's coming back as an integer. Give me back that integer value from our sales order header table where the order dates fall in one of these values. And if we execute this, we'll get back where these things live. You can see here that this is January 15th of 2007. Remember, we defined our partition function as range right, so our first partition starting on January 1st is actually the partition number 2, and that's what that's indicating. And you can see here are dates that don't fall exactly on the boundary, but within the boundary values. And so we can see we have a date here for the 3rd, 4th, and 5th partition as well. So just an example of how we can use the partition function to indicate, hey, here's a partitioning key value. Where does this particular value fall? What partition does it belong to? It does not guarantee or indicate whether or not that value actually exists in that partition, but it's at least telling us where it would if it did. SQL Server exposes information about itself, system objects, and user-defined databases through catalog views. Not only does SQL Server use these views for its own operation, but you as a developer have access to them as well. There are several catalog views available to us for retrieving partition information. And refer to SQL Server 2012 Books Online for information on additional catalog views. Some of the more useful views are as follows. We have a partition functions view, a partition range values view, partition schemes, and data spaces. Let's take a look at some of the details for each of these. The syspartition functions catalog view returns information about defined partition functions. The columns that are important to remember in this view are the name, it's the partition function's name, the ID assigned to the function, that's the function ID column, the type of function, whether it's a range function or not. The fan out indicates the number of partitions actually created by that partition function. And then there's a bit value called boundary value on right. If set to true, that means it was defined range right, otherwise range left. If we want to get information about the boundary values defined within a particular partition function, we can use the partition range values catalog view. Very straightforward. It contains the ID assigned to the function, the ID assigned to the boundary, and its range value. Getting information about a particular partition scheme is straightforward because we'll use the partition schemes catalog view. It returns to us not only the name of the partition scheme, but its data space ID, which is internal to SQL, the type of scheme that it is. In this case, PS indicates a partition scheme, and then the internal function ID, the ID associated with that partition function. Finally, if we want to discover information about the file group mappings for a particular partition scheme, we can use the data spaces catalog view. And it will return to us the name of the partition scheme, the data space ID, and the file group type. And it'll indicate by having a type of FG that it's a file group. So let's go ahead and take a look at some examples of using the catalog views. So here we are back in SQL Server Management Studio, and we're going to take a look at using some of the catalog views to gain information about our partition functions. This first example is going to retrieve information directly from the sys partition functions catalog view to give us the basic details about the partition functions defined. So we'll go ahead and execute that, and as you can see, there's only one defined at this point. It's our sales by quarter partition function. It has its internal ID displayed there. You can see that it is a range type partition. There are 5 partitions defined. That's the fan out. And because we defined it as range right, you can see that the boundary value on right bit is set to true. In our next example down here, we're going to take a look at the specific range values assigned to each of the partitions in our partition function. And here you can see that we're specifically going against a particular partition function, the one that we've defined, our sales by quarter PF, and we want to find out what the values are for those boundaries. So we're going to take a look at the partition range values catalog view, and we'll go ahead and execute that. And we can see here the values assigned to the given partitions. We can see that our boundaries are January 1st, April 1st, July 1st, and October 1st, corresponding to our 4 quarters for the sales year 2007. So very simple to use, very simple to get information back, and we're finding the details of those boundaries using this catalog view. So let's move on here. I'll close this, and we'll go ahead and take a look at the information about the partition schemes using our partition schemes catalog view first. We should get some information back about the partition scheme we created a little bit earlier, and sure enough we do. It indicates that we created a partition scheme called sales by quarter PS. We know that it's a partition scheme because its type is indicated there as PS. And if we want to find out information about the file groups associated, we can simply take a look at the data spaces catalog view, and you'll see here that this is the data space used by the primary file group. That is what SQL creates when the database is created. You can also see here data spaces 2 through 7 are corresponding to our the file groups associated with our individual partitions. And you can also see down here at the bottom that there's a data space defined for the partition scheme itself, and we realize that it is not a file group because it is indicated here as type PS, which stands for partition scheme. But the point here is that you can find out not only the name of the individual data spaces, but what type it is. And here it's very clear for us to see that in our particular case, it looks like we have a one-to-one mapping between partition and file group. So this should be a pretty flexible model for our partition table.